Hi, my name is Keri Herman. I am currently a math secondary education major at Grand Valley State University. I am taking Math 496, which is my capstone course here. We have been working all semester to learn about the importance of games being used within a classroom. My goal for this semester was to create a game involving multiplication facts that is not timed or strictly focused on memorization. I designed a few different multiplication mazes with one solution to each maze: a 5 by 6, 7 by 8, and 9 by 10. All mazes are completed, they just need to be printed out in black and white ink. No color is needed. Each player will need something to write with. The mathematical objective of these mazes is for students to practice multiplication facts without the pressure of being timed. While going through each multiplication fact, students will be moving the amount of spaces in the ones place of the product. This is also a great way for students to notice the relationships between multiples and products. There is a fun hidden pattern within that students may be able to recognize. In each maze, there is only one solution. You will start at the top left square and find your way through the maze to the bottom right square. In each square, there is a multiplication fact. Once you have the product of that fact, you can move the amount of spaces that are in the ones place of the product. An example would be if you land on a square with 9 times 8, we know that the product is 72, so you can move 2 spaces. You can move on the board either left or right, or up and down. If the ones digit of a product will move you off the board, try a different path. When you are moving along the board, think of this the same way as how you would move in a regular board game. Here is an example where we start on the space with 6 times 7. We know the product of that is 42, so we can jump 2 spaces. Then we land on 9 times 5, and the product of that is 45. We quickly notice that 5 spaces will take us off the board, so we know that we have to go back and start back at 6 times 7 and try to go a different way. You are finished with the maze when you land on the bottom right square without passing it. If you get stuck, how could you use the idea of knowing where you want to end up? A cool thing to note is that the 9 by 10 maze has every multiplication fact forward and backwards at least once. I hope that you enjoy solving these mazes, but what I really hope is that you can make your own. Here is how I figured out how to make them myself. First, you will want to determine the dimensions of your maze. Here I am drawing a 5 by 5 grid and marking the starting point in green and the ending point in purple. You will then make your own path from the green space to the purple space, trying not to move the same amount of spaces to get a variation of products in the solution of the maze. Make sure that no spaces that you land on within the path can lead back to the path in another way, creating a shortcut. It may be helpful to have a multiplication table for reference when choosing the multiplication facts that you are going to put in your maze. Since this is a 5 by 5 maze, I start by crossing off the multiplication facts that I don't want to use. For example, any multiplication fact that ends in 0 or anything over 5. Now we can begin filling in multiplication facts that are suitable for the path that we created, crossing them off on the multiplication table. For example, we can see in the path you have to jump 4 spaces to the next spot, so the product of this multiplication fact needs to end in 4, so I put 6 times 4. Now continue this same process. This is what your maze should look like at this point. You can now cross those facts off of the multiplication tables. Now I go through each square on the board, not including the maze, and count the number of spaces that will lead back to the maze, and the product cannot end in that number. For example, in this space, it takes 2 spaces to get back to the green, so the product cannot end in 2, 3 spaces to get to 7 times 3, and 4 spaces to get to 9 times 8, so the product cannot end in 2, 3, or 4. We can also look at this square here for an example. Since there are no leads to the path, either left or right, or up and down, this space can have a product that ends in any number. You will now repeat this process for every square on the maze. Now you can go through and fill in the multiplication facts. For example, in that square, the only number the product could not end in was 1, so we could choose any product that ends in 2 through 5. So I chose 6 times 9, which is equal to 54. The top right square cannot end in 1, 3, or 4, so I chose 4 times 8. You can then cross all of these products off of the multiplication table and continue this process all throughout your maze. You can then go back and double check each space and make sure the product does not lead back to the maze path. Here are the listed steps for the development process. I hope that you are able to make your own, and I hope that you enjoy solving my mazes. Thank you!